So for 1b, we're being asked to integrate 1 plus sine x over cos x, and they're telling you to use u equals sine x. So the first thing we always do is differentiate it. So differentiating sine x gives us cos x, and rearrange this to get dx all on its own, so that's du over cos x. Any purists there arguing about that? Well, it works, so get over it. So this integral, we're going to have 1 plus u over cos x, and instead of writing dx, I've got du over cos x. And they're not cancelling, and that's why I think this exercise is quite a tough one. But we could just say that that's a cos squared x on the bottom. Now we can't integrate that. We've got x here, so we're going to have to continue playing with this. And remember that cos squared, of course, is 1 minus sine squared. And sine squared is, or sine is what we had here. So this is 1 minus u squared. Made a mistake there, didn't I? That should say du. And at that point there, we then have to remember our difference of two squares. We've got 1 plus u times by 1 minus u there. And finally now, these two things can cancel. We can integrate the integral of 1 over 1 minus u to be the ln of 1 minus u. I've also got that minus to deal with there, so I'll put a minus outside it. So the answer is minus the ln of 1 minus sine x plus c. So the substitution bit actually was over here, and then there was a lot of work to go and do after that, even though you'd done the substitution.